is the Happy Scientist Podcast. Each episode is designed to make you more focused, more productive, and more satisfied in the lab. You can find us online at bitesizebio.com/happy scientist. Your hosts are Kenneth Vogt, founder of the executive coaching firm Vera Claritas, and Dr. Nick Oswald, PhD, bioscientist, and founder of Bitesize Bio.
Hello and welcome to another edition of the Happy Scientist Podcast. This, of course, is the place to be if you want to become a happier, healthier, and more productive scientist. I'm Nick Oswald, the founder of bitesizebio.com, and today we will be drawing on the wisdom of Mr. Kenneth Vogt, Bitesize Bio's Mr. Miyagi, and the founder of the executive mentoring company Vera Claritas. Today and in all other Happy Scientist podcast episodes, you get to benefit from Ken's Yoda-like or Mr. Miyagi-like words of wisdom to help you increase your performance, enjoyment, and success in the lab. Today's episode actually has the best episode title so far of any in this series. It is I Hate Maths and Organic Chemistry and Applied Physics. Okay, Ken, what is that all about?
All right. Well, I want to start off with your side of the pond says maths. My side of the pond says math, singular, no S. But it all means the same thing for anybody who might be confused by hearing the other word.
Or it's all the same for anyone who hates them.
Well, there you go. You know, it's kind of funny. I'm not a scientist, as I've said many times, but I am actually quite erudite when it comes to math. So you might be thinking, well, I'm going to give you a math tutorial today. Nothing could be farther from the truth. That's not what we're going to do. I want to talk more about the underlying foundation of this and why people have this math anxiety. And it's funny for the average person out in the world thinks, well, all you nerds are the same and you're all good at math. And of course, so many scientists are saying, well, don't let me in with that. Math is frightening. To my mind, and to use a musical analogy, math is digital, whereas biology is analog. And for anybody who's a musician out there, you know that there's a big difference between the two. And yet, they end up at the same place. And, the argument can be made that everything is made out of math. So you're already doing math. It's been a part of the science you do for a long, long time. And you've just been telling yourself that you're not good at it. Or other people have told you that. And it might be that somebody said you're not good at math, or some group that you're part of is not good at math. Like girls are not good at math. Whoever said that, what a crazy thing. Or any other group. You can say they've been told over and over again they're not good at math. And I don't know how it was for you in school, Nick, but for me, I noticed that it became socially acceptable, even at a very young age in primary school, for people to say that math was hard and it's okay to not be good at it. When no one would say that about reading, no one would say that about social studies or about science or about anything else. But math you were allowed to not be good at. And well, all that did is foster this lack of confidence because, let's face it, what are we confident about? We're confident about the things we're good at. Well, how do you get confident about something? Well, you go look good at it. And often we don't start off that way. And come on, think about it. In your scientific career, did everything just come easy? Did you have to work at nothing? Were there no rough patches? Were there no hard parts? Come on. You've been doing this all along. Now, another part of the psychological part about math is that we don't like to look bad. And we fear we're going to look silly, we're going to look stupid if we're put in a situation where we have to demonstrate our lack of math skills. But, we have to get past that. The fear of looking bad. I mean, it's middle school drama. Sometimes you got to be able to laugh at yourself. Sometimes you got to be able to say, you know what? I need to put in a little more effort. I need to try a little harder. And so, that's what we're going to talk about here.
Yeah, I think that one of the problems with maths in particular, and actually that does apply to organic chemistry and applied physics, is that when you look at it to begin with, it doesn't click straight away. It never will. You have to, it's not just something you grasp intuitively normally. You have to sit down and just give it yourself some time to absorb it. So, not like reading a book or something like that, or learning a biological concept. Most of it, you can see it on the page and you can start to understand it straight away. Maths is from the beginning just looks, what the hell? And then you have to overcome that and get into it.
Yeah, it's very foundational, very fundamental, and it's very structured. And I think that actually will speak to a lot of people who are scientists. Knowing that there's a structure in place that you can rely on is pretty useful. So I mean, that's what mathematicians have striven to do over the years, is to create those foundations. And so, that's where you get things like theorems and axioms. A theorem is, a hypothesis, as it were. It's something that has to be proven, and theorems are proven, and so we use the proven theorems to build more science. But the proof that it's built on is axioms. Axioms are just accepted principles that can't be proven. Now, you might look at that at the beginning and go, well, that's a crazy thing to base anything on. Yeah, well, guess what? Take a look at biology. Biology is axiom rich. So we're not asking you to call on anything here that you aren't already using, aren't already doing. It's not actually that hard of a step from science to math. And I'll use the same idea when it comes to things like chemistry. Yes, chemistry takes a very different look at things than biology does. However, it's looking at the same things. So, maybe you're looking through the front door and they're looking through the side window, but they're looking at the same thing. and a chemist would probably argue it's the other way around. They're looking through the front door and you're the one looking through the window. It's all already there. So the first thing you got to do is take a look at theory versus reality. So you've told yourself, or others have told you, that math is dull. And well, sure, it's dull if all you ever look at is just the raw theory of it. But if you start applying it to reality, math can get actually pretty interesting. And maybe you've had that experience already in your life. And like, for instance, math can be very interesting when you're investing or when you're gambling. You start doing the math on that stuff and it starts to get kind of fun. Why? Because there's a practical use, there's an outcome, and you get it and you like it. And the idea that, wow, we can save up enough to have a down payment for a house, all of a sudden that math is pretty fun to do. Because there's an end there that is useful to you. And so, this is something that's always cracked me up. That even people that don't complain about math will complain about word problems. And to my mind, word problems were always the place where we finally got to make use of this math. It wasn't just theory. It wasn't just esoteric knowledge. It was some practical application of this thing. And it's one of the reasons I personally got interested in application software, because, there's fundamental software, operating system software, and stuff like that. And I watched some guys get very excited about that, but like, I wanted to see where the software would be useful, where it would touch people's lives, where it would accomplish something. So it's the same kind of thing with this. When you start to realize there's math affecting my work in the lab, for instance, probability and statistics. Statistics in the lab is very, very important. And arguably statistics is one of the more erudite regions of math. It's one of the harder areas. And I know some of you out there are groaning right now. It's like, oh, I hate statistics. but think about how critical a part of your career they will be. How they can how they can make you famous. They can make you a star. They make all the difference in a good paper. You know, when somebody says, "Here's all the data we collected, but now here are the principles we've extrapolated from that. Here's what we have learned from that data." And what you learn from the data is often right there in the stats. So you got to get in there and make application of that math instead of just thinking it as just of this hard stuff that's over there on the side. Start seeing it as an integral part of your world and not fearing it as an integral part, but like, okay, here's a tool, a very powerful tool that I can use. And I understand it's fair to be afraid of powerful tools. um if you got something that can start a fire, you got something that can blow up, you got something that can shoot projectiles, yeah, you should treat that with respect. And math is kind of like that. But when you need to start fires and you need to blow things up and you need to shoot projectiles, it's really useful. So, if you didn't have that tool, you'd really be shackled. You'd really be hamstrung. So, so start to appreciate the value of the chemistry and the physics and the math as they apply to your job and your career, and realize, okay, you've taken on hard things before, you can take on the next hard thing. Another thing you can look at with this is one of the things that's our initial experience with math is, what do? We learn addition tables and we learn multiplication tables. And it's this bunch of memorization. And that memorization, for most people, is boring. Some of us were, mentally built in such a way that wasn't boring, but that's not true for most people. Most people found it boring. And then they just extrapolated that to all the rest of math. Well, all math must be boring. Not so. The problem solving part of math is very interesting. It requires imagination. It's a lot like, say, science. So, when if you're going to look at it, it's just, oh, this is just a bunch of tables I have to remember. Oh, yeah, well, yeah, who's going to want to do that? And worse yet, here's a bunch of tables I'm going to forget.
I'll tell you, I remember organic chemistry at university was, oh my God, you mean we just have to memorize this stuff that has no connection to each individual? There's no logic, there's no pattern. I mean, there is eventually, but to begin with, you just had to remember all of these different reactions that happened. And yeah, that's the sort of stuff that I didn't like. But how, and then later worked with organic chemists in the lab. Once you know the stuff, then it's real, once you go layers in, you allow it to mature. What they can do is amazing. So
Yeah, it's tools that they've learned how to use. And the fact is, if you've been working in the lab a while, you have learned to use an impressive set of tools that, for an outsider looking in, going, how could anybody ever learn to use all those different things, or learn all these different techniques, all that stuff they teach at Bitesize Bio, you know? But the fact is, you do learn it, and you learn it because it's useful to you. So start recognizing that math is useful to you. It's going to get you places that there's really no other way to get to. And it's not about, well, no, I have to climb a mountain now. There's no road around it. And I didn't want to be a mountain climber. I just wanted to be a driver on the road. Well, you are going to climb some mountains. I'd love to tell you that life is going to be easy and it's going to be a walk in the park, but there are some hard things to do. There are some things you have to make commitments to. And you may find, like, look, when I started down this road of scientific endeavor, things were coming easy to me. I got it. Things were exciting. I saw patterns that other people weren't seeing. It was just flowing for me. But when I got to math, the flow wasn't there. I was like, all right. So what do you do in a situation like that? Well, I'll bet you that is also a description of part of your journey in learning science. Some parts of it flow. and other parts of it did not come easy at all. Well, what did you do? Well, here's what you did if you got through it, and here's what you need to do if you haven't got through it yet. First off, get some help. Now, and the first person you can get help from is yourself. And you start that with just an attitude adjustment. If you're all doom and gloom about it, if your reaction is just nobody can learn this, it's too hard, I don't have time, I don't feel like it, this is too boring, it's too taxing, it's and you just keep layering pejorative after pejorative on it. Well, how is that helping? What is that doing for you? Is it giving you an excuse? Well, now I don't have to learn math. Yeah, right. Is that going to work? You're going to have to do this stuff. It's part of the job. And here's a reality of this. If it's a part of the job that just makes it, this is just a bridge too far, I can't do this, well, then you're looking in the wrong career. Now, when I say that to you, I'm sure some of you go, whoa, wait a minute. I love this career. All right, then. Well, then do what it takes and adjust your attitude.
It's interesting because, I mean, the extension to this is, as you mentioned statistics before, but, a lot of people, I'm not saying everyone, of course not, but a lot of a lot of biologists' approach to statistics are slapdash at best. And I say that as someone who was like that in the lab myself, because I got other people to do it for me, and that was really bad. I mean, I should have taken it was my responsibility to fully understand. I mean, I had a working knowledge of the statistics that I needed to use, and that was it. But as a scientist, you must know it, and there's no excuse now. There's no excuse now for not doing the spade work that's required to get enough of an understanding that you can be fully responsible for the statistical analysis that you need to do yourself. There's no excuse. There's so much around. That's going to be one of the major focal points for Bitesize Bio over the next year, is trying to is putting out some great resources for statistics and maths and experimental design and things like that, because that is one of the slapdash attitude to that is one of, in my view anyway, is one of the reasons for the reproducibility crisis and things like that we're seeing.
Oh yeah, it's going to be career destroying for some folks, because they're gonna phone in some statistics and then they're going to get taken apart by peer review, and people are going to say they're being dishonest.
Yeah, and then it gets, or it doesn't get taken apart and they get published, and then it becomes part of the literature. And so anyway, it's really important. And there's a great book, actually. I mean, there are a lot of good books about stats and statistics for biology, but there's a great book called Lab Maths, or how we would call it lab maths, but it's Lab Math. It's written by an American surname. We've had her talk on Bitesize Bio before. It's published by Cold Spring Harbor Press. It's Danny something. Lab Math, Cold Spring Harbor Laboratory Press. Danny Spencer Adams, her name is. That's a great book for getting you mainlining into exactly what you said, the practical application of mathematics that you need to use specifically for your job. So that's the fastest way into that sort of book, is the fastest way into past the dry stuff and into what you need to know.
And one of the things we've mentioned application now over and over again. Well, another word for application is action. That is, you're actually going to use it. A lot of times, if we're afraid of something, something like math as an example. If you're afraid of math, your fear comes before you start doing the math. It keeps you from doing it. Well, one of the ways out is to start doing it. And when you start doing it, it's not as scary, because now you're seeing, you're not afraid of what it could be. You're seeing the problem, whatever problem you're dealing with right in front of you. So now it's specific. And as things get more specific, it's more manageable. And you can actually get passionate about math or chemistry or physics as you are about biology. It's possible. Because look around, there are people that are passionate about those things. And I'm sure you know some scientists that are also passionate about chemistry and physics and math.
And by the way, once you can start to get passionate about that, you will become more passionate about your biology because you'll feel more confident in the full gamut of knowledge that you need to do that thing, rather than that's my experience of it. I worked as a biologist, molecular biologist, and that you can be pretty much in the rails working in just cartoon models in a way, and not really going into the hard side of the science. But then I went to work for a company, I've mentioned this in the podcast before, where I was working with chemists, and I was blown away by their precision of knowledge and understanding of the math and stuff like that. And so I took it upon myself to expand my knowledge in chemistry specifically, and what that transformed the way biology looked to me.
Sure.
It's definitely a thing that's worth spending the time on doing. And by the way that I did it, and that was even 15 years ago, was I listened to I just got some lectures that, university lecture series from, I can't remember what university it was, but at that time they were publishing was a podcast, and I just did the course, and off I went.
Well, there you go. I mean, one of the things we can do then is get tutored, and there's lots of ways to do that, as you pointed out. And in modern day, there's really lots of ways. I mean, there are YouTube channels on this and podcasts about this, and there are free university courses on this, and there are inexpensive paid courses available. And you can actually get a tutor, or you can talk to the chemists in your own lab if you had a lab like where Nick was, and get some pointers from people that are actually doing the work on the ground. You can read books. You can, there's so many possibilities. So this notion of, well, I never got a chance to learn it before. Well, then take the chance now. You've never had more of a chance.
Yeah, it really is so worth it. It's very exciting to fill in those dark areas, those gray areas that you kind of understand but don't understand. Even I did 2 years of chemistry at university, but I'd forgotten it all by the time I got to that time in the lab, or I'd never applied it, so it never really had any life breathed into it. But so I kind of thought, yeah, I can kind of understand what that guy's talking about, when he's giving the lab meeting. But I'd never really understand. You don't really breathe life into until you start using it in the lab. And so, or till it connects up with your everyday work. And once you start doing that, it's very exciting. It's really good.
Yeah, for many people, their best learning method is hands-on. So having taken the course or read the book, I mean, there's some stuff rattling around in their brain, but until they put their hands to it, they don't really learn it. So, and especially if that's your typical style of learning, it is imperative that you put your hands to it. And what Nick, you just said something that was very, very key a moment ago. You may not ever get excited about the math, but you might very well get excited about the hole that it fills in the work that you do. So I don't, you may not care that you're doing statistics right now, but what I do care about is that I'm wrapping up this paper and getting the final conclusions spelled out. Okay, there's a piece of this that really matters to you. Well, math is just a tool. It'll get you there. And it's a lot better than trying to do it without tools. It's like eating your porridge with your fingers. Just a spoon makes all the difference.
It's so easy to kid yourself that you kind of know enough as well. Really get immersed. Especially if it's something you've done in university. Yeah, I did those stats. I did that statistical, learned that statistical treatment in university, so I can kind of know what's going on. That's fine. But no, it's much better if you just get in there. It's like going to the gym. You know what I mean? You can go to the gym and go once a month, or you can really get in there and do the job.
Yeah, and you can go there and just putter around and
Exactly.
not really get a workout.
Yeah, it'll float all boats. So yeah, definitely worth getting over that hump. I'm not sure about the applied physics, but just kidding.
It's funny. In my mind, applied physics is like the most stripped down version of math application. So, but I mean, and of course, physics doesn't affect everybody's work in the lab, but it does have certain impacts on certain techniques that you're using, for instance.
Well, I mean, you do electrophoresis, very simple technique. If you understand how current flows in a solution, you're in a much better shape than if you just put it on and leave it and hope it does the job.
Yeah, I was thinking about something completely different. So I'm glad you said that, because I'm like, oh, well, I never even thought about that. But I was thinking about using centrifugal force. Well, there is some basic physics there, and man, that's useful in the lab. Think all the things you do that involve centrifugal force.
Yeah, definitely.
So, all right. So the bottom line is, stop telling yourself you're not good at math. Stop telling yourself you hate math, because you're just, all you're doing there is you're hiding from something you have to do. So stop putting it off. Stop fighting it. Use the tools that are available out there. Get some help if need be, and that you can get that help very privately by watching a video or listen to a podcast. If you don't want to let anybody else know that you have a weakness in that area, you don't have to. On the other hand, if you can get over yourself and have a little humility, you can get up to speed very quickly by telling somebody that knows about it, hey, I don't understand this, can you help me? And you could be over something in a week, in a day, in an hour. Something you maybe have been fighting your whole life, and you have the key to get out. So this is the way out. So I hope this helped.
That known unknowns thing is that you talked about before. Once I started looking at more into chemistry, suddenly the whole connection between math, chemistry, biology, and physics started to become more and more clear. I was like, wow, that's amazing. It's just, you can be so, I mean, I don't know how I managed to go through my whole, undergrad, PhD, and first couple of years postdoc so blinkered as to what science was really. But anyway, that's another story. Hopefully it's just me.
Oh boy, I don't know. That sounds like a great episode there. The blinkering of Dr. Oswald.
Yeah. Well, yeah, it's definitely, anyway, can't say that enough. It's definitely worth going outside the comfort zone and adding layers of skill set on there.
Yeah, we've talked about comfort zone before too.
It's all connected.
It is. So that's what I've got for today, Nick. Anything you want to add?
No, I think that I said most of what I would have to say in that during the during this. But again, it's one of the things that we realize at Bitesize Bio in general, that it is, at least in our collective experience, this is an issue, and so we will be we're bringing some great people in to help us create materials that will help people to easily dive into the math and on chemistry and stats and stuff that will really help them to grow as a scientist. So maybe we can come back and do another version of this episode in a year's time, and we can tell the people what resources they can specifically go to to do that. So, okay, thank you, Ken. That was an interesting one. Great title.
Thank you.
And thank you to all the people who listened in as well. I hope you got something out of that. If you did, please come to facebook.com/The Happy Scientist Club and tell us, and join us and follow us, and we can interact with you there. You can tell us what you would like to hear and so on. Also, if you've just reached this podcast because it's near the top of the pile on Spotify or wherever, and you want to dive in deeper, obviously they're all there on Spotify, but if you go on to bitesizebio.com/The Happy Scientist, you can see all episodes there and get more of an overview of what this podcast is all about. So that just leaves me to say thank you, Ken, for another great episode.
Thank you.
And we'll see you again next time.
Bye now.
The Happy Scientist is brought to you by Bitesize Bio, your mentor in the lab. Bitesize Bio features thousands of articles and webinars contributed by hundreds of PhD scientists and scientific companies who freely offer their hard-won wisdom and solutions to the Bitesize Bio community.